Hello there, knowledge seekers. Welcome back to LearningHub, where we decode the mysteries of AI one concept at a time. I'm your host, and today we're diving deep into the fascinating world of knowledge representation. But first, a brain tickling question. What do your brain, a library, and a well organized computer program have in common? The answer: they all use clever ways to represent and manage information. If you want to be a part of this amazing journey of AI, subscribe to Learning Hub and press the bell icon so you never miss amazing content like this. In our last video, we talked about knowledge itself. But how do we actually store and use that knowledge in AI systems? That's where knowledge representation comes in. So, hang on, grab your thinking caps and let's get started. Knowledge representation, or KR, is basically a way to take all that fuzzy, complicated knowledge floating around and turn it into something a computer can actually use. Think of it as translating human thoughts into machine language. It's all about finding a way to structure knowledge so an AI can process it, reason with it, and ultimately make intelligent decisions. Now, you might be wondering, why go to all this trouble? Well, without good knowledge representation, our AI systems would be stuck in the Stone Age. They wouldn't be able to reason, learn from experience, or even understand basic instructions. Good knowledge representation allows AI to infer new knowledge, solve problems, and even explain its reasoning. It's the secret sauce that makes AI, intelligent. Also, knowledge representation provides a foundation for building intelligent agents that can perform actions based on what they know. This is crucial in expert systems, where the goal is to mimic the reasoning and choice-making processes of human experts in specific domains. Alright, let's talk about the superpowers that make a great knowledge representation system. First up, representational adequacy. This means the system needs to be able to represent everything that's important in a particular domain. Imagine a system for diagnosing medical condition. If it can't represent symptoms, diseases, or treatments, it's going to be about as useful as a screen door or on a submarine. Next, we have inferential adequacy. This is all about the system's ability to reason with the knowledge it has. It needs to be able to draw conclusions, make predictions, and answer questions based on the information it's given. Now, let's consider how efficiently the knowledge can be used for inference. Inferential efficiency is the system's ability to incorporate new information into its knowledge structure and use it for inference. For example, a system learning new symptoms for a particular disease over time. Now, let's talk about acquisitional efficiency. This refers to how easily the system can acquire knowledge. Can it learn from data automatically? Does it require a team of experts to manually enter every fact? The easier it is to acquire new knowledge, the better. For example, a system that can learn new vocabulary from text or images is highly acquisitionally efficient. Okay, let's go around this with some real-world examples of knowledge representation system. First up, we have semantic networks. Think of these as visual maps where concepts are connected by relationships. It's a wave of knowledge. Next, we have rule-based systems. These systems use if-then rules to represent knowledge. For example, if the patient has a fever and a cough, then they might have the flu. It's like programming with logic. Last but not the least, we have frames. Frames represent knowledge as a collection of attributes and values, similar to a database. Think of it as a structured way of storing information. Now, it's not all sunshine and rainbows in the world of knowledge representation. There are some serious challenges. One is capturing common sense knowledge. How do you teach a computer that water is wet or that birds can fly? It's surprisingly difficult. Another challenge is handling uncertainty and vagueness. The real world is messy. Things aren't always black and white. How do you represent probably or likely in a knowledge representation system? Finally, there's the challenge of scaling up. Building a knowledge representation system for a small, well-defined domain is one thing. But what about representing all the knowledge in the entire world? That's a massive undertaking. So, there you have it. Knowledge representation is the key to unlocking the true potential of knowledge. By finding clever ways to represent and manipulate knowledge, we can build systems that reason, learn, and solve problems like never before. The choice of knowledge representation system depends on the specific application. While semantic networks excel at capturing relationship between concepts, knowledge representation or rule-based systems are better suited for encoding expert knowledge. Therefore, selecting the right approach hinges on understanding the requirement of the task at hand. And that's a wrap of our discussion on knowledge representation systems. Don't forget to like this video, subscribe to Learning Hub for more mind-blowing content, and share your thoughts in the comments below. What are some of the most interesting applications of knowledge representations that you've come across? Until next time, keep learning, and I'll see you in the next video.